Before we begin developing physically based materials with the Arnold standard surface, we need to finalize our environment lighting to get accurate previews. We've got environment lighting in the scene already, but we want to change that up a little bit. So let's select the sky dome, go over to the Modify panel, and we'll see down here in Color Intensity we do have a texture map assigned. Let's edit that texture map. To do that, we'll want to open up the Slate Material Editor. Click on that button. Once the Slate Material Editor opens, let's drag this texture map button over into the Slate Material Editor view. We get a pop-up dialog asking if we want to instance or copy this map. We want to choose Instance so that any changes that we make in the Material Editor will actually affect the sky dome. So choose Instance and click OK. Now we see a node in our graph, and that's the OSL HDRI environment map. With it selected, let's rename it. We'll call it ENV map. Just to verify that that map is actually instanced into the sky dome, we can refresh the command panel. We see here down here it still says map number something. We can switch over to the create panel and then back to the modify panel. That refreshes the display, and now it says ENV map there. Okay, let's render this. Right-click in the physical camera viewport and choose from the main menus Arnold Render View. And as before, click to initiate an interactive production rendering. We get very soft shadows and suffuse illumination. This panorama was taken on a cloudy day. Let's store this in a snapshot to compare it to other renderings. And we can swap out that HDR image for a different one. Back in the Slate Material Editor parameters, in the HDRI file, we can click to Browse. And in our current project Scene Assets Images, I've got another one, Urban Courtyard 4K monochrome.hdr. Again, a modified version of a file from the website hdrihaven.com. Select that and click Open. The Arnold Render View will update automatically, and we can see that we'll need to change the exposure. Back in the sky dome parameters, under Color/Intensity, Exposure, let's bring that up to a value of +2. This panorama was taken on a partly cloudy day, so we're actually getting some hard shadows. We can rotate the environment either by rotating the sky dome or by adjusting the rotation parameter here in the map. Let's do it in the map. I can click and drag on the rotation spinner and release the mouse, and we can see that the light has actually moved. Let's set the rotation amount to 100 degrees. And now we've got pretty strong key lighting coming from camera right, and that's going to better approximate the lighting in my final rendering. We can store another snapshot to compare this version. Click to create a snapshot. Here's the rendering on a cloudy day, and here's the rendering on a partly sunny day. And this is going to be better because it's actually going to show the highlights and specularity a little bit more clearly. Okay, I'll go back to a live interactive production rendering. We also want to make sure that the exposure is correct. And when we're developing materials, we don't want to have underexposed or overexposed previews. To set the exposure, we can temporarily assign a bright white material to all objects. Over in the Slate Material Editor, we'll create an Arnold standard surface. In the Material Map Browser, we'll see Materials and Arnold. We can open that up if it's not already open. Surface, Standard Surface. Drag that over into the view and select it, and let's rename it Ideal Diffuse. To make this perfectly white, we'll increase the base color weight, bring that up to a value of 1. And to make it perfectly rough, we'll set the specular roughness to a value of 1. Now we can assign this to all objects in the scene. From the main Max menus, choose Edit, select All, and with that Ideal Diffuse material selected in the Slate Material Editor, click the button to assign the material to the selection. And again, the Arnold Render View updates, and we can see that it's slightly overexposed. We can verify that by viewing the pixel data, and that's done by clicking on this little gear over here. That's going to show the display panel. Then we can go over to the Pixel tab and move the mouse around, and we can see statistics for the pixel underneath the mouse cursor. We don't want any of those RGBA, Lume, or display values to be over 1. So we'll reduce the sky dome accordingly. So I'll reselect that sky dome. Select the sky dome only. Right-click in the physical camera to give focus to that once again. And then in the Modify panel, we can change the exposure value. Let's bring it down to a value of 1.8. And then as we move the mouse around in the Arnold render view once again, we'll see that those values never go over 1, which means that we're not overexposing our shot. Okay, we can close that panel once again. At this time, the Arnold render view does not support the 3ds Max exposure control. And that is assigned to a physical camera when that camera is created. So in fact, right now, physical camera exposure control is enabled, but the Arnold render view does not show that. So we can go into the rendering menu to exposure control. We'll see that exposure control is enabled. Well, let's just turn it off because it's not actually doing anything. It's going to work in the active shade or production render windows, just not in the Arnold render view. I'll set the exposure control to no exposure control. And just to make sure that in fact nothing really changed, I'll go back to the Arnold render view. And in the Arnold render view menu, we can choose Render Update Full Scene. That's going to force the render view to reread all of the scene parameters. And once that's done, we can see that nothing has changed. And that proves our point, once again, that currently exposure control is not supported in the Arnold render view. All right, we'll close the Environment and Effects dialog and go back to the Slate Material Editor, which I've got minimized down here. I can restore that. And now we want to create our first proper material. It's going to be a black plastic. We can just take the existing standard surface and duplicate it, hold down the Shift key and drag to make a duplicate, and with that duplicate selected, rename it Plastic Black. Now let's assign it to the chassis of our ham radio. We can actually select objects directly in the Arnold render view. And just to show that, if I hover my mouse over that chassis and then click, we'll see that that object was selected in the viewports. And we can see its Modify panel parameters. Then we can go over to our standard surface. With that node selected, we can go up to the Material Editor toolbar and click the button to assign the material to the selection. And then make some changes. Go over to the base color. Click on the color swatch and reduce the value. Bring that down. We want this to be black, but not perfectly black. It's not really possible for most materials to be exactly perfectly black. We'll bring the value down to 0.002. And now it's nearly black. Click OK to close that color selector. And let's change the specular roughness. That's going to determine the glossiness of the surface. With a roughness of 1, the specular highlights are going to be very scattered. Let's reduce that roughness. We can bring that down, just drag the spinner, and when we get down to very low values, we start to see reflections that are kind of coherent. Let's set the roughness to a value of 0.4, and that corresponds to plastic. The other very important property of the standard surface is the IOR, or index of refraction. That's going to determine the reflectivity of the surface at different angles to the camera. And that'll be easier to see if we go over to our perspective view. Click in that view, and then we can orbit or tumble around in the view with the Alt and middle mouse button. Maybe select an object and then orbit around that object. We can also zoom in or dolly in with Control Alt and middle mouse. Get in real close so we can kind of see the backlit top of that plastic surface. And with that framing, it'll be a little bit easier for us to see how IOR works. As we increase the IOR, or index of refraction, we'll get greater reflectivity on the surfaces, whether they're facing the camera or not. If we reduce the IOR, we'll tend to get the result of surfaces facing towards the camera will not be as reflective or shiny, and surfaces that are pointed away from the camera are still going to be more reflective. So let's set the index of refraction to 1.3. All right, so now we've got our first standard surface. I should mention as an aside that we can use the 3ds Max physical material in this workflow, but I prefer to use the Arnold standard surface because it supports more features such as the round corners map we're going to be using later.